The overall goal of this procedure is to trigger an orientational transition of a liquid crystal in response to temperature, and to characterize the transition.
This method can help answer key questions in the liquid crystal field, such as thermodynamic surface anchoring behaviors. The main advantage of this protocol is that the orientational transition can be clearly visualized in a discontinuous manner, and the involved physical properties can be systematically probed.
To begin this procedure, prepare 1 milliliter of perfluoropolymer solution by dissolving the desired perfluoropolymer in a commercial solvent at a ratio of 1 to 2 to ensure uniform films 0.5 to 1 micrometer thick for spin coating. Next, wash glass substrates by sonication at 42 kHz in an alkaline detergent. Then, repeatedly rinse each substrate with distilled water. After rinsing and drying the substrates, subject them to UV ozone cleaner for 10 minutes. Following this, drip 20 microliters of the perfluoropolymer solution onto each cleaned glass substrate. Immediately spin coat the solution at 3,500 RPM and room temperature for 70 seconds. Then, bake the film at 80 degrees Celsius for 60 minutes to remove the solvent, and at 200 degrees Celsius for 60 minutes for curing. Apply a photocurable resin pre-mixed with micrometer-sized glass particles to one of the film-coated glass substrates. Then, place a second film-coated glass substrate on top of the first substrate